Okay, so the next question that we have is a survey regarding the heights in centimeter of 51 girls of a class of a school was conducted and the following data was obtained. So you have a survey regarding the heights in centimeter of, so you have the heights in centimeter of 51 girls of a school was conducted and the following data was obtained. So we have basically this table over here, which is basically height in centimeter, and then we have number of girls. So when the height was less than 140, the number of girls was 4. When the heights were less than 145, the number of girls were 11. 150, 29. 155, 40. 160, 46. And 165, 51. So when the height was basically less than 140 in centimeters, less than 140 basically 4 girls, less than 145 11 girls, less than 150 29, and so on and so forth. So that means that basically as you come down this list, basically is more and more classes are being added to these classes, meaning that we can write this as less than 140, and then you have basically less than 145. So you can go from, we could write this as, for example, now we could write this as, for example, 140 to 145. We could write this as 145 to 150. We could write this as 150 to 155. And then you can write 155 to 160, and then 160 to 165, 165, and this you can write it as, for example, below 140, right? So these are your classes. So as you can see, when you have the frequency relate of the less than type, as you can see the lower limits of the 140, 145, and the upper limits of the original classes are used in the less than that. And of course it makes sense because it has to be less than this or less than this, and so on and so forth. So now to find the median height, what you need to do is that first you need to find the median class. So the median class is basically, and to find the median class you need to know your n. So your n is basically the sum of all of these numbers. So you can write as basic, this is 15, and let's say this is 30, so 45, 44, 84, 124, 130, 180, 181, I suppose. 181. If I'm not mistaken, right? No. But these are of course not the frequencies. This is the cumulative frequency. This is CF. This is CF related to these classes. You need to, from your CF, when you have your CF, then of course the number of girls would be basically 51. This the last number over here, which is, of course, since we are here about the less than type, then of course the number down here becomes your n, and of course you can see over here that it says 51 girls, so you know it from here as well. So what that means is that then you have 51, basically you have your n is equal to 51, so then that means that n divided by 2 is equal to 25.5. Now 25.5, you have to go for the cumulative frequency of the class. You have to go for the class whose cumulative frequency is greater than this number, which is basically this class over here. So basically this class over here, you can call this the median class. You can call this the median class. And once you have the median class, then what you need to do is, then again you can simply find what you need to do. Basically you need to find basically the frequencies of each of these classes as well. These are the cumulative frequencies. So based on these frequencies, you need to find f of I as well. F of I as well. So this becomes your f of I, and then you can calculate it based on these numbers. So that means, so now less than 140, the number was the cumulative frequency of basically less than 140 was 4 girls. And then less than, for example, so that means that the frequency related to this class can be 4. Now we said that less than 145 is 11, right? And that of course includes this class as well. So you have to basically subtract from 11 this number, and then you will get the frequency related to this class alone. So 11 minus 4 is equal to 7. And then over here we said that less than 150 was 29. So 29, you have to subtract from 29 both of these numbers, which is 15, 29 minus 15, which is equal to 14. 29 minus 15 is equal to 14. So that's a 14. And then 40, you have to subtract all of these numbers from it to get to the frequency of this class, which is basically, this is 29 plus 11 plus 4 is equal to 15 plus 39, which is equal to 29 plus 15, which is equal to 44. And this doesn't make any sense. oh, I'm sorry, this number is already in this number, so I have to just simply write 29 minus 11. So this number would be simply 4. This number will be 11 minus 4, which is 7. This number is 29 minus 11, which is 18, right? This number is 40 minus 29, which is 11. This number is 46 minus 40, which is equal to 6. And this number is 51 minus 46, which is equal to 5. And if I add all of these numbers together and we write them properly, 8 and 4, 8 and 4, so that's 11 plus 11 is 22, 30, and 40, and 11 is, so this is 22, 30, and 41, right? And that's 18, sorry, that's 18, so that's 51. So now, again, it's important to understand how to write the frequencies of these classes, meaning that, of course, it's a simple logical thing, but you need to make sure that you don't make logical mistakes. Meaning that, for example, when you say the cumulative frequency of all the students less than 140, that of course becomes the frequency of basically this class. Then when we say less than 145, of course, less than 145 includes these students as well, right? So then, when you want to find the frequency of the students between 140 and 145, which becomes this class, you have to subtract from 11 these students, which is 11 minus 4 is equal to 7. Again, when you want to find the frequency of all the students between 145 and 150, you have to subtract from this cumulative frequency these students and not include this number as well. And the reason for that is that basically these students are already in these, basically this number is already in this number. So, meaning that these numbers have been added together. 4 plus 7 is 11, then 11 plus 18 is equal to 29, 18 plus 29 plus 11 is equal to, well, 40, and so on and so forth. That means that this number is already in this number, and this number is already in this number, meaning that this number is already in this number, this number is already in this number, and so on and so forth. So what that means is that then when you want to get for example, get the frequency of all the students, for example, between 145 and 150 centimeter, all you need to do is subtract 11 from 29, which is 29 minus 11 is equal to 18, right? Again, 40 minus 29 is equal to 11. 46 minus 40 is equal to 6, and so on and so forth. Now, once you get your numbers in this manner, what you need to do is that n divided by 2 is equal to 25.5, and so in order to find your median class, you need to go for the cumulative frequency, which is greater than 25.5, which basically is not 11, so it's equal to is 29. So this class becomes your median class. This class over here becomes your median class. Now, once you have your median class, then you need to use this formula. Then you need to use this formula, which is median is equal to L plus N divided by 2 minus CF divided by F times H. Okay, it's not easy to remember these formulas, meaning that when you don't understand where a formula comes from, you will forget it. But for example, in the case of this formula, since I thought about it a little bit, I kind of have some idea how it's been put together, and for the same reason I could write it on my own. Otherwise I would have had to look at the book while writing the formula, right? And of course, even some of the concepts you will forget. I mean, I do forget these concepts, some of these concepts very often, especially the ones that I don't use on a day-to-day basis. On a day-to-day basis, I do mathematics, but for example, statistics is not the kind of thing that you do every day, so you forget them, really. So sometimes you have to go back and read something again to remember them. Now, what we have here is now this formula. Now in this formula, L is the lower limit. I don't have to write all of these down. L is the lower limit of the median class, which is 145. So this is 145. And n divided by 2 is basically this number 25.5. Basically this thing over here is the cumulative frequency of the median class preceding the of the class preceding the median class, meaning that this basically cumulative frequency 11 minus 11, and you divide that by the frequency of the median class, which is 18, not the cumulative frequency, but the frequency of the median class, which is 18, and divide the whole thing and multiply the whole thing by the class size, which is 5, right? So this is equal to 145 plus, well, this is 14.5 times 5 over 18, which is the same thing as, I don't know, there is no way to simplify these. 5, 10, no way to simplify. So 145 times 5 is equal to 25, 2, 20, 22, 2, 22, 2, 5, 7, and you have 1 decimal 72.5. 72.5 divided by 18 is 3 times 20 is equal to 4 times 20 is equal to 80. I think 4 times and then 4 times is equal to 8, so 72. I think I think, let's see, 18 times 4 is equal to 72. 4 times 18 equal to 72, 0, and 5, then 0, 0. 2 times 18 is equal to 16, 1, 2, 36. So this is a 14, and 0, 0. 5 times 20 is equal to 100, 6 times 20 is equal to 127 times 20 is equal to 140, so we put 7, 56, 5. So you can take that as 4.03, right? So 4.03, so that's 145 plus 4.03, which is the same thing as 149.03. If I haven't made any mistakes. Sometimes I do make mistakes, hopefully not. Which is this thing over here, 149.03, which is exactly right. So the median height of the girls is 149.03. This means that basically, so what that means is that this is the median height. This is the median height. This is the median height. And what that means is that about 50% of the girls are less than, have basically heights less than this height. And this is in centimeters, of course. 50% of the girls have heights less than this height, and 50% of the girls, or you could say about 50% of the girls have heights more than this height. So that's basically another example, and let's do one more and then we will wrap this up. I think we are at the end of this section. Graphical representation of cumulative frequency distribution. Yeah, we are at the end of this section. Okay. So let's do another example here, and there is some more information here that we can review together as well, and then that's about it. And we can go back to the chapter that we were doing actually. Okay, so now another example here. We have the median of the following data is 525. So we have this data here. So you have basically these class intervals. You have these class intervals and the frequency related to them. And then you have basically 0 to 100, 100 to 200. You have 200 to 300, 300 to 400, 300 to 400, you have 400 to 500, you have 500 to 600, 600 to 700, 700 to 800, 800 to 900, and 900 to 1000, 900 to 1000. Now, the frequency related to these are 2, 5x, 12, 17, 2, so we have 2, 5x, and 17. I'm sorry, 12. 2, 5x, 12, 17. 20, y, 974. Okay. This is basically the list of numbers that you have, or the data that you have, and that is your data. So let me and one thing that is always important, never be in a rush. it's not a good idea to be in a rush. Always do everything properly. Okay, so now I know that the median of this data is equal to 525, and I want to basically find the value of x and y here. So first, of course, I need to find the median class. So the median class here is basically, you need to basically find the, so if your median is 525, then the cumulative frequency of these classes, are basically 2 plus 5 is equal to 7, and this would be 7 plus x. This would be basically 12 plus 7 plus x, which is equal to 19 plus x. And over here you have 17 plus 19 plus x, which is 17 plus 19 is equal to 16, 20, 36 plus x, 56 plus x, 56 plus x plus y, and 60, 65 plus x plus y, and 72 plus x plus y, and 76 plus x plus y. So now the frequency f of I, sigma f of I, is going to be basically the all of these numbers added together. So that's 7, that's 19 plus 17, and I have an x over here. 19 plus 17 and x over here. So this is 7, 19 plus 17, and you have 29 and 11 over here. 29 and 11. And you have a y as well. So then this is equal to 16. 16 plus 10 is equal to 26. And that's 40, 60, 76. So your n is equal to 76 plus x plus y. So then what I can do, n divided by 2 is equal to 76 plus x plus y divided by 2. 76 divided by 2 is 35. 38 is equal to 38 plus x divided by 2 plus y divided by 2. So now how can I find the now what I need to do is that if this is the value of n divided by 2, I have to go for the class whose basically whose cumulative frequency is greater than this number. So over here, for example, I have now you somehow need to reason your way out and find out one of these. So for example, if you go for this one, this could be provided that x is greater than 2 plus x divided by 2 plus y divided by 2, then this is greater than n divided by 2. Let's see how they have solved the problem. I remember the last time I couldn't solve this problem. 76 plus x plus y. Oh, okay, so we know that the frequency is equal to 100. The frequency is equal to 100. So if n is equal to 100, so that means that x plus y is equal to if n is equal to 100, based on this you can write 76 plus x plus y is equal to 100. And what that means is that x plus y is equal to 100 minus 76, which is equal to 24. So x plus y is equal to 24. And also okay, so you know that x plus y is equal to 24. And the median is equal to 525. And it seems that you already know in which class it lies. Oh, okay. But of course, if the median is 525, there is no, you already know in which class it lies. I was not really thinking. See, when the median is 525, that means that it already lies in this class, because 525 is greater than 500 and less than 600, so this is your median class. You already have everything that you need. So this is your median class, and it lies in this class. I'm sorry, your median lies in this class. And so what that means now is that then we need to just apply the formula. The formula was the median is equal to L plus n divided by 2 plus CF, or I don't know, it was minus CF. Minus CF, it was of course divided by F times H. So the median is 525. L is the lower limit of the median class, which is 500. And n divided by 2 is n divided by 2 is 50, right? N divided by 2 is 50. Now the cumulative frequency of the class prior to the median class is 36 plus x, right? 36 plus x. So that is minus 36 negative x. Yeah, you have to multiply the negative by both of those terms. It's negative 36 plus x, so it becomes negative 36 negative x. And then you have divided by f, which is the frequency of the median class, which is 20. Divided by 20, and you have to multiply the whole thing by h, which is the class size, is 100, which is the 100. So now you can, 5 times 20 is equal to 100. That's a 5. And then you can write this as basically 525. 525 is equal to 500 plus 5 times 50 minus 36 is equal to 14 minus x. 14 minus x, which is basically, that's all. We don't need this anymore. And so 525 is equal to 500 plus 5 times 14 is equal to 50, and 70 minus 5x. So 55 times 4 is equal to 20, 70 minus 5x. So then this is 570. So negative 5x is equal to 525 minus 570. So 570 minus 525 with a negative sign. 5, 6 minus 2 is equal to 4. So that's negative 45. Negative 45, these two you can cancel out, and x is equal to 9. And we said that x plus y is equal to 24. X plus y is equal to 24. That means that y is equal to 9 plus what is 24 is 10 plus 9, no, 24 minus, basically y is equal to 24 minus 9, which is equal to 15. So your y is equal to 15. So that is basically that. X is equal to 9, y is equal to 15. So that's basically how you find the median. Of course, these are not that important here. It's not, I mean, it's not really a problem to work a little bit on these, but basically the concept is important. How you apply this formula, because we want to use these concepts in the basically coming videos. So now there is only a couple more things here to discuss, and it's basically only some a little bit of theory here. So it says that now that you have studied about all the 3 measures of central tendency, let us discuss which measure would be best suited for a particular require. So we have basically learned about the mean, we have learned about the mode, and we have also learned about the median. So now we want to decide which measure is best suited for a particular requirement, meaning that where you're supposed to use the mean, where you're supposed to use the mode, and where you're supposed to use the median. Okay, so now let's see what we can do with these 3 things. So the mean is the most frequently used measure of central tendency because it takes into account all the observations and lies between the extremes, that is the largest and the smallest observations of the entire data. It also enables us to compare 2 or more distributions. For example, by comparing the average results of the students of different schools of a particular examination, we can conclude which school has a better performance. So this is important, because when you think about for example, when you think about the process of calculating the mean. Of course, no matter how many observations you might have, of course, mean is basically, mean takes into account all of your observations, and then it lies between the extremes, meaning between your minimum and between your maximum. It lies somewhere between the minimum and the maximum. Here is your mean, and all of these observations that you have over here, it takes into account all of these and all of these, and gives you some value over here, which you can use in order to, for example, compare the in order to compare the basically two or more distributions. Meaning that, for example, let's say that these are the results of let's say that these are the results of, I don't know how to represent this mathematically. For example, the results of school A in a certain examination, okay, and then you have also the results of school B in the same examination and school C. So when you take the mean of all of these results, and also the mean of all of these results, and also the mean of all of these results, then you can say basically that basically which school, or basically which students basically have done better on average, basically on the same examination. That way you can compare. Meaning that you can use it for comparing performance. Okay, so that's basically about mean. Now about now then the rest of this is basically how the rest of this is, however, extreme values in the data affect the mean. And then of course that is of course a problem with the mean. If you have basically extreme values in the data, that does affect the mean, meaning that suppose that, for example, you have for example, let's say 1, 2, and you have basically 1000, for example, 1001 and 1002, right? So you have all of these, you have these basically 4 observations here. Now you see that basically this observation, the value of this observation is 1000 times the value of this observation. The value of this observation is again about 1000 times the value of this observation, and also that is also the case with this observation. And if I add all of these numbers together, I get 3004 divided by 4, which is going to give me something like around something about 800 or so. So that means that basically then the mean of these values is 800. So 800 is not a very good representative of basically of the data that I have here, as opposed to the case where if I had, for example, 1000 and 1001 and 1002 and 1002. In this case, I would have the mean of this would be, for example, 3003 divided by divided by 3, which is equal to 1000. So 1000 is a much better representative of these 3 observations than 800 is of that 800 then I'm sorry, I repeat my sentence. 1000 is a much better representative of these 3 observations than 800 is of these 4 observations. 800 is, if you want to compare these 2 sets of observations, 800 is very, very far from 1. And so when there is extremes in your data, then you will get into such problems with mean. For example, the mean of classes having frequencies more or less the same. For example, the mean of classes having frequencies more or less the same is a good representative of the data. But if one class has frequency, say 2, and the 5 others have frequency 20, 25, 20, 20, 25, 20, 21, 18, then the mean will certainly not reflect the way the data behaves. So in such cases, the mean is not a good representative of the data. So what that means is that, for example, in the case of it says that the mean of classes having frequencies more or less the same is a good representative of the data. Meaning that, for example, let's say that you have these classes 0 to 10, for example, 10 to 20, and 20 to 30, and 30 to 40. Right? You have these classes over here, and then you have these frequencies of, for example, 3, for example, 2, 1, and 3. This is f of I, and this is basically, these are your classes, and then you can call your x of I would be this, which is basically, for example, over here your x of I would be your, for example, your class mark, which is equal to 5, over here is equal to 15, over here is equal to 25, and over here you have 35, right? So now if I were to find the mean of this data, I would write this as x bar is equal to sigma f of I times x of I over sigma f of I. Now sigma f of I over here is equal to 5 plus 3, 5 plus 4, which is equal to 9. It's going to 9. And over here sigma, then f of I times x of I. F of I times x of I is equal to, for example, 15, 30, 25, and that's 105. Adding all of these numbers together, you get 45, 65, 70, 175. So 175 divided by 9, 175 divided by 9 will give you, for example, will give you 19.4. 19.4. So that's the mean of this data here. Here x bar is equal to 19.4. Now, let's suppose that we have another set of basically data over here, something like, for example, the same classes, let's say 0 to 10, for example, 10 to 20, 20 to 30, and 30 to 40. And then over here, what I will do is that I make the, for example, I use the same, for example, the same frequency here, but all of a sudden I make this a 15. And for example, 1 and 2. 1, even make it a 3, right? and then my x sub I over here are going to be the same values, meaning 5, 15, 25, and 35. And then f of I times x sub I would be equal to 15. 15 squared is 225. 25 and 3 times 35 is equal to 105. And so this is going to be about 40 and 145. 145 plus 200 is equal to 345, 365, 370. 370, and your f of I is equal to something about 4 and 7, 722. So here your x bar is equal to 370 divided by 22, which is equal to 16.8. 16.8. So you see that the mean shifted about 2 units. The mean shifted about 2 units, essentially for just you could say minor change in just one of the frequencies of just one of the classes. So what that means is that that's basically why it says that the mean of classes having frequencies more or less the same is a good representative of the data. But if one class has frequency, say 2, and the 5 others have frequencies 20, 25, 20, 21, 18, and so on and so forth, then the mean will certainly not reflect the way the data behaves. So you need to be careful about that, of course. So in such cases, the mean is not a good representative of the data. Now, in problems, so let me clear this up. So in problems where individual observations are not important, and we wish to find out a typical observation, the median is more appropriate. That is, finding the typical productivity rate of workers, average wage in a country, etc. These are situations where extreme values may be there, so rather than the mean, we take the median as a better measure of central tendency. So here it says that in problems where individual observations are not important, and we wish to find out a typical observation, the median is more appropriate. That is, finding the typical productivity rate of workers, average wage in a country, etc. Because in these situations you get all of those extremes, and when you get to those extremes, then the mean is not going to be a good representative of your data anyway. So these are situations where extreme values may be there, so rather than the mean, we take the median as a better measure of central tendency. And in situations which require establishing the most frequent value or most popular item, the mode is the best choice. That is, to find the most popular TV program being watched, or the consumer item in greatest demand, or the color of vehicle used by most people, etc. So that's basically where you use basically mode, right? And as a remark, there is an empirical relationship between the 3 measures of central tendency, which is basically an empirical relationship between the three measures of central tendency, between the three measures of central tendency, which is basically 3 times median. 3 times median is the same thing as mode plus 2 times mean. 3 times median is equal to mode plus 2 times mean. And number 2, this is remark number 1. Remark number 2 is the median of group data with unequal class sizes can also be calculated, but we're not discussing it here, so that's not the problem. That's not for now, but basically this relationship exists between the three measures of central tendency, meaning that 3 times median is equal to mode plus 2 times mean. Mode and mean and median. Okay. So that was basically all the review that we needed to do. I think we have covered all the important basic concepts in what do you call it, the statistics. And now we can go back to our chapter over there and then talk about whatever it was that we were talking about. We were talking about I think I don't really remember. I have to go back to that chapter and see what we were doing over there. Now, if you have any problems with if you have still problems with these concepts, what you need to do is that you need to go back to chapter 14 of you need to go to ncert.nic.in to this website, and you go to class 10 and chapter basically mathematics, and over here again mathematics, and go, and you will find this book over here. This is mathematics for class 10. And then you will go to chapter 14 of this book, which is statistics. This is the chapter that I was explaining in these 3-4 videos, or I guess it was more than 3-4 videos, something about that. So you need to go over here to this chapter and go and work through this chapter. What's important here, we have basically talked about all of the concepts here. All you need to do is basically go and do the exercises. For example, exercise 14.1, you have a bunch of exercises here. It actually took me a few days to work through this chapter the previous time I was doing it. So exercise 14.2, for example, you have all of these exercises. You have 14.3 as well. These are, no. You have 14.3 somewhere over here. This is exercise 14.3. And there is still some basically material over here, the graphical representation of cumulative frequency distribution, which is not very relevant right now as far as I can guess. If it's relevant, then we will go back and do this part as well. Otherwise, not very important, at least for now. So now, in the next video, we will go back to I don't know where I was. We will go back to chapter 15 of class 11, mathematics. We will go back to, this is mathematics for class 11. Chapter 15 is statistics. And we will do this chapter now. You have access to the same website, so you can open it and follow along. So I'll see you in the next video.